Because you are muted, please use your reactions to communicate in terms of right now. I need you to indicate if you can see the screen. Can you guys see the screen? Just a reaction. Thank you very much. Okay. The last time we covered a section of soils, right? And we spoke about a lot of things relating to soil and how the chapter on its own is structured. We spoke about mostly the soil identification or identification of soil. Under the identification of soil, we covered field identification. How is soil identified on site or with the naked eye? How can you see the type of soil you're dealing with? We spoke about different characteristics such as color, consistency, a lot of things that we covered. The hardness of the soil. We spoke about soil samples, moisture content. Why is it important in soil? The consistency part. What does it mean? We said is the resistance of soil to flow, and we said that the soil can move from different stages, being liquid, solid, or semi-solid. We spoke about relative density or density in general, whereby we said that it is achieved by proper compaction. And then the particle size distribution, we had already covered the previous week. So I said the particle size distribution and the soil volume characteristics, we're going to continue with them today as well. We spoke about the classification of soil, the soil survey procedure, or the site investigation, and then I explained why are they important and what is it that you need to note moving forward. And then we stopped at compaction, right? And we said we're going to continue from compaction moving forward, conclude the chapter. So compaction, we said that compaction is the process of densifying the soil. So they use different construction plants such as, or equipment, such as rollers, tampers, and or vibrators, right? So what happens is when we were talking about compaction, we said that we want to, when we were introducing the chapter, we said in a soil profile, you are gonna have soil that is moist. If the soil is moist, you're gonna have solid particles, water, and air, right? The spaces that are filled with water and air, we call those the voids. Number one, if the soil is completely dry, in terms of a soil profile, you're going to have only solids and air. And then all the voids will be filled with air. And then we said, if you are compacting, the main point is to make sure that we densify the soil. What do? We remove the air voids. What does that do in terms of volume? It decreases the volume of the soil and the soil will be more dense. So they say that compaction results in a reduction in volume. So that's how it results in a reduction in volume, because if a soil in its natural state, it's loose. If you need to compact it or make it or move it from that loose condition to a compacted condition, when you look at the volume of the loose material, it will be larger, and the volume of the reduced soil or the compacted soil, in that state, it will have smaller or less volume as compared to the other one. So they say that the effect of compaction can be measured by dry density. Measurement of compaction can be determined in the lab using the CBR and on site. So we have different ways we can determine the compaction. One of them is when you determine the optimum moisture content and the maximum dry density. Note that when they refer to the compaction, they will also say it can be measured by the dry density. It's a test that we are also going to do in the lab. So basically what we do is we get soil and we compact it. So the soil, we have different basins, maybe 4 or 5 of them, all 7 kgs of soil, completely dry, and we add water in it. So in the other one, we'll add 4%, maybe 6%, 8%, 10%, depending on what we want to achieve. And then that soil is compacted, right? So what happens is during that process of compaction, different compaction efforts are used, but mostly it's different layers. So we do it in different layers. If maybe the first one we did 5 layers, the first 3 we did 3 layers, and the other one will be different. So what happens is you will have a graph that you will have to draw, and then you will indicate the maximum optimum moisture content and the maximum dry density. So that's how they do it. In terms of the understanding of how do they do it, you will see it in the lab if there are maybe confusions relating to compaction itself. We do have a test relating to that where you determine the dry density. Therefore, you're able to see how the compactive effort changes or how it affects the density of the soil or the layer of that particular soil. So they say that construction plants mostly used rollers, tampers, and vibrators. We already said that. So the other part that we need to deal with is quarries. What are quarries? Quarries are specific places, right? So if you're going to have a construction, for example, we're constructing a road, and then we do the site investigation. On the site investigation, we realize that our preliminary tests indicate that the soil that we have here is not suitable for use. Then what happens is they will look for a quarry. A quarry is a specific area that has to be identified as a source for a particular material. So if we realize that the soil that we have, because we're going to extract it, right, or excavate, and then we realize this soil, we cannot really do anything with it because it will not be able to withstand the loadings that we are expecting to impose on this layer of the road. What happens is sometimes they need to excavate it all together, move it, and then store it somewhere. They're going to store it somewhere, and then they will have to have a place whereby they're going to collect material that will be suitable. So those are the quarries. If you realize, if there's any time maybe you've seen a road construction, when you'll see these big cars, truck loaders, they'll have soil in them, and then they will be transporting it to site. It is from the quarry. Depending on the type of material is needed. So the extraction of the suitable material is done through explosives. So they need to have explosives, and then it helps them extract the soil because sometimes there are hard rocks, and therefore you can't just use maybe excavators to get the soil, right? And or maybe in terms of where the layer of the soil that we need, maybe if it's deeper towards the surface, it's deep from the surface, then it means that certain tools cannot be used, right? So the process is called blasting, and bulldozers and front-end loaders are used to transport the soil. So they will just use explosives to make sure that they make the soil loose, and they then move the soil from the quarry to site. The process of blasting is dangerous and strict safety procedures are used. Yes, it is dangerous because they use explosives. Engineers in this part, technologists, technicians, they're not responsible for that. They need to outsource people who deal only with that, and then they help them with the extraction of the soil. So when you're developing a quarry, as they say that soil studies are carried out to identify the type of rock as well as the uses, right? So depending on, are we going to use it, the material, are we going to use it as a sub-base, a base, or we're going to use that material to surface the road, right? So when you're surfacing the road, maybe you're using aggregates. Those aggregates, either it's a 19 millimeter, and then on top of it, you're gonna lay maybe a 9.5. So if either or, the query will be developed in terms of what kind of material do we need and what are we going to use it for, right? So sometimes they will collect the material for either the layers of the road, the base, sub-base, subgrade, or for the surfacing. So they will blast or use explosives to fragment the rocks and then use crushers, right? So they will crush it to a 19 millimeter. So if they say we are going to need a 19 millimeter, they're going to use explosive, crush, explode, and then the material that they will get, it will not be that small, right? And if we're saying we need a 19 millimeter only, then you need to use the crusher to crush the same rocks that they have to that specific size. If it's a 19, then it will be a 19. If it's a 9.5, then it's a 19 because the 19 is too big. On top of it, you need to lay something else so that the road surface can be smooth, right? So they say proper layout planning of the site is also important to determine the following, right? So you need to make sure that when you're developing a quarry, you look into things such as the quality control, geological influences, slope angles, excavation of the material, traffic on haul roads, quarry planning in relation to the layout of the quarry. All these things in terms of quality control, will the material that you're going to get, will it suffice or will it be exactly what you need for that specific use or that specific layer? Geological influences such as where is the quarry? Is it next to residential areas or not? Also, wherever it is, if maybe you need to excavate some land that might have that rock that you need, it might belong to someone, then maybe you need to strike a deal or whatever it is that you need to do for them to allow you to use their site or their land as a quarry. The slope angles in terms of, because remember, when these we are collecting the soil from the quarry to site, so all these trucks that are loading the soil will have a load, and therefore you cannot have a steep slope because you're going to have a problem. Excavation of the material, how is it going to be excavated? Traffic on haul roads. Will you be joining a road that is highly loaded with traffic or low volume traffic road, and how will it work? Will you need people to kind of make sure that people know that they need to slow down because there are trucks joining traffic and they're very slow? If someone is coming maybe at a speed of 120 and the truck just joined, maybe it's on 10 kilometers per hour, then this person might have a problem because if they're too close, the stopping distance might not be enough for them to stop in time so that an accident does not appear or it does not occur. So things like that. Quarry planning in relation to the layout, the whole layout as well. If maybe you're going to say this will be the layout of the quarry, this portion will be used for excavation. We're going to excavate from this point. This point we're going to use to crush and store that soil or the rocks or the aggregates for a specific time. And then the loading will happen here, and all of that, it needs to be planned accordingly so that you don't have issues. Um, so they say that geologists are responsible for determining the amount of rock that can be extracted from the quarry. This becomes the deciding factor of the actual size of the quarry as well as its usefulness. Test holes are used to determine where and to what extent solid rock will be used. Dust is a health hazard, therefore it is important to minimize it in everything. So in every quarry, because they're going to use explosives, we are going to have a problem of dust. And if your quarry is next to a residential area, then you will have to work harder to make sure that you minimize the dust as much as possible. So even if it's not next to a residential area, you still need to make sure that you minimize the dust, because it's a form of pollution. And in every aspect of construction, even in the design process, they try as much as they can to make sure that they use sustainable methods to reduce the level of pollution, either noise, air pollution, in terms of vibrations as well. So all those things, they need to be minimized, right? So the roads, they have the requirements as well. So there are requirements for roads that provide access to site, right? So from the quarry to the site, then you will need to have roads that are in good conditions. And these are the requirements. They say that the road has to have a good design and maintenance. The reason for that is because of the loading that will be imposed on that road. Because the trucks will be carrying heavy loads. Therefore, it has an impact on the road pavement as well. Because I think as you move forward, you will realize, I think also in transportation 2B, yes, transport 2B, that's where they talk up, is it 2A or 2B? I think A. That's where they talk about the loads or the stresses on the road in terms of the wheel load, because the loads will be transferred from the actual soil that is carried, the actual weight of the truck, it will be transferred to the wheels. And therefore, because the wheels are the ones that are in contact with the road, therefore we need to make sure that we have a good design and maintenance. If the road was initially designed for a lower volume or loading, it means that deterioration will happen very fast, and therefore that will call for good maintenance and good design as well. Correct slope from the crushing plant to the work face. This is, we discussed already, that they will be moving from the crushing or the quarry itself to the actual section of the road where we are transporting the rock or the soil, and therefore the correct slope, because the trucks are carrying a heavy load. The roads must be kept in good condition and have adequate width, so that if there's a need for other cars to overtake, they're able to do so, because these trucks, they travel in very low speed because of the heavy load that they carry. No sharp curves, because accidents will happen. Heavy load as well. Level loading area, make sure that they don't overload the truck. Sometimes they would want to overload, but what happens is the problem will be, as they're traveling, will have air, and then the soil will be disturbed, as well as depending on the slope, then we might have problems. They must not have a gradient of more than 1:9, and then the roads must also be smooth. So these are the requirements of the roads that will be used to carry the material from the quarry to the specific section. Either we will call it site, but in terms of roads, then they will deal with roads in sections. So if you're building maybe just a mall, then there's no need for sections because the whole site, you will just call it a site. But in terms of the road, then they'll say if it's a 10-kilometer road that they are doing, then they will cut it into different sections. So depending on where you're going, that section of the road. So the road that you're using that will lead to that specific section, it needs to have those requirements, all of them. Dust control and rehabilitation requirements. We said that dust is a major problem on site because there is an extraction and transportation. Therefore, dust control measures need to be put in place, especially if the site is next to a residential area. How do they normally do it? They will use water. Uh, Water tanks will always be on site in this case because they will continuously be spraying the quarry to make sure that as these trucks move from to collect and they leave that specific area, they don't produce a lot of dust. So they're constantly spraying that area with water to make sure that they minimize it. In terms of rehabilitation, they say rehabilitation is an important process that ensures the area is reconstructed and it blends in with the surrounding landscape once the query is used up or the work is complete on site. So there are regulations and rules governing queries, their development, and how the place must be once everything is completed. So what happens is you will leave the place as it was, right? So they're not allowed to leave any holes or they excavate and then they don't bring in any substitute material to cover that hole. So that's what they're saying. They say if you have a quarry, you need to make sure that when you leave, it's as if there was no quarry before. Um, it's important so that the area will blend in. So the query must blend in with the surrounding area. Of course, we understand that in terms of vegetation, you might not be able to achieve that immediately because you will give the area time to maybe have that vegetation. But in terms of soil, there must not be any holes left there and everything or any hole. You must make sure that you find substitute material that you will use to make sure that those holes are closed. And then when they're talking about the blasting, they say blasting is a process whereby the original rock deposit is fragmented using explosive devices or drilling methods so that it can be transported from the rock face to the crushing plant. Drilling is done according to the type and amount of rock needed. Different explosives are used depending on the type, size of the material. The blasting design has different consideration and factors required to break a given rock material, rock type. The blasting process, like we said, blasting is a process whereby we're going to fragment or sometimes, just think about this, there are roads that when you look at it, you see that before this thing was a mountain, but now it's no longer a mountain because there's a road through that mountain, not in a form of a tunnel, but they just removed that part and then they use it for, it's now a road, right? So they also use blasting for those considerations. So they will go there, use explosives. The engineers are not responsible for that. They outsource people to do that who are qualified to do it. These people will get there. They will be told, this is the type, this is the rock that we are going to get from the site. We are looking for the initial size to be this big or that small. And therefore, then they will come with the blasting design and the method. that is suitable to produce whatever it is that you need. So if you need smaller fragments, then they will have a design for that. If you need bigger fragments, they will have a design for that as well. Hazards of blasting: fly rock, air blast, ground vibrations. Fly rock, whereby because you're using explosives, normally if they are blasting in an area, right, and then they have a road that passes through that place, they close that section of the road so that no cars are allowed to pass, and then they do the blasting, and then only once everything settles and they make sure and they're sure, and they're sure that nothing will explode further, then only then do they allow traffic to pass by. Because if it's an explosive, then rocks will be flying around. It's not safe for people to be close by. Air blast is the air that will be produced because of the blasting. So if you have a smaller blast or a bigger blast, then the air blast that you're going to get will differ based on the type of blast you get. Also, the other thing that they have a problem with is ground vibrations. That's why it's very important to know where is your quarry. Are there residential areas? Yes or no? If there are, then you need to be more careful, because in anything that you do, you can't have explosives that will cause any cracks in people's houses or structures, because if there are ground vibrations, then they're bound to affect the foundation. If a foundation is affected, then things might happen. So that might lead to cracking as well. So you need to check table 1.7 and table 1.8 on your books when it comes to this. So they will have a section in your books as well, whereby they explain thoroughly. Fly rock, we said that these are the rocks that will be flying around because of the explosives. When the actual explosion happens, the air blast is the air that will be produced, because when you're dealing with air, if you don't understand in what way, look at it like this. If you have let's say if you're at the beach, right, and there's air is strong enough to move fragments. If you're at the beach and you're walking and then there's air, it has a way of moving or transporting those sand particles, and they are very strong. So in terms of air, even though it's something that you don't see, but it does have an effect, because also when you during the design process, they also look at the wind load, right? So if you do not take that into consideration enough, then you'll have the problem with air, even though it's something that we don't always experience, but it's important to cater for that as well and look into it. So there are rules when it comes to blasting. One of them is that if you're blasting next to a road, you need to make sure that you take safety measures by not allowing cars to pass by during the actual blasting, because maybe a person might be driving and they do the explosion, and then maybe they get frightened, they lose control of their car, and then it's a problem. Sometimes to control the ground vibrations. So normally, depending either or, they will have smaller, they will cut the section in small sections, do a blast, do another one, maybe have smaller blasts than one big one to control the ground vibrations, also depending on where are you blasting as well. So look into that, because those are factors as well. The other part that we need to cover is the stabilization. What is the stabilization? So we said that when we are doing your sieve analysis and all these tests, preliminary tests that you do, you do them because you want to find out the suitability of the material. Will I be able to use the material? Yes or no. If the material you can't use it and you find that it's not that bad, I can stabilize the soil. Stabilization is the process of improving soil and make it more stable. How do you make it more stable? There are ways you do that. What are the advantages? The advantages include the following: increased strength, improvement of durability and resistance to the effects of water, wet soils can be dried, improvement of the workability of clay soil, cemented layers possess good loading spreading properties, right? So these are the advantages. We said mostly when we talk about it, I will be referring to strength or density. So these are the additional points to note as advantages of stabilization. And the different types of stabilization. We have mechanical stabilization, and then we have other stabilization where they use either cement, lime, bitumen, and all those other things. So what is mechanical stabilization? Mechanical stabilization is the mostly used method that relies on the properties of the soil material for stability. If compaction alone, okay, first before we move to that part, they say mostly used method that relies on the properties of the soil material for stability. You go to site, you do tests, you find out that the soil is not stable, is not suitable, and it cannot be used. Before you even go to stabilizing with cement or whatever it is that you might want, the first thing you need to find out is, if I look into the properties, is there no way I can maybe alter or kind of maybe introduce other aggregates? If maybe your soil was gap graded, introduce other aggregates to make sure that the soil is well graded so that the soil is more stable. So the mechanical stabilization, it relies on the properties of the soil itself without you adding anything on it, right? If compaction alone does not produce the required stability, then additional soil aggregates are added to produce the required stability. Also, in terms of the properties of the soil, do you have clay soil? If yes, then maybe what you can do is heat the soil or do whatever to the soil to make sure that you kind of alter. In terms of what is it that you can change on the soil, it might be the plasticity index, because the cohesiveness of the soil, depending on the clay percentage on the soil, then you kind of manipulate it in that way to make sure that you get the desired results. Cohesion and internal friction of the soil are important factors in mechanical stabilization. By cohesion, they mean that it's a force that holds the particles together. And what is internal friction? It's a force that resists the movement of particles. These will deal with them moving forward, because also in terms of slopes, it's important that you look into that as well. So types of mechanical stabilization is stabilization by compaction, stabilization by consolidation, stabilization by electric and thermal methods, and lastly, soil aggregate stabilization. By compaction, the main objective is to have good compaction that will lead to the increased load, reducing the possibility of settlement and minimizing stages in moisture content. Stabilization by compaction, they talk about settlement. It's the first time we come across this word. Let's make an example. If you have a stockpile is a pile of soil whereby, let's say you're excavating soil. Remember I said, okay, you have a section of road, you realize that, oh no, man, this material that we have here is not going to be suitable. we're gonna need to move it, right? Okay, you move it. If you move that soil, you're going to pile it somewhere. That we call a stockpile. That stockpile, we have the possibility of experiencing settlement. Settlement is whereby, because when you transport it, what will happen is the smaller particles, they will tend to go and settle at the bottom. Therefore, if you have a stockpile and maybe you take a sample of a sample of the soil at the top of that heap, and you go to the bottom and you collect the sample at the bottom, you find out that if you grade those samples, those two samples separately, they might give you a different grading curve. Why? Because of settlement. And then they talk about minimizing changes in moisture content as well. Stabilization by consolidation, they preload the soil to reach the required stability. So what they'll do is, if they know that, but this one, this type of stabilization needs more time, because you will load the soil or the layer where you're going to have a load, right? So what happens is, if you take, let's say you have a layer of soil, right? Okay, you are at the beach and you are walking at the beach, right? If that soil or the layer, it has water in it, if you step on it, what happens is the water will be squeezed out. And then you see that there is a compaction effort, that your whole body, you will see your foot there, right? It means that that soil was loaded, right? If you remove, your foot, the soil will not go back to the um, original state unless the water comes in again, and then it disturbs that soil or that section of the sand. So look at it like that. Look at it in terms of, you have that soil or piece of land, you stress it, or you impose a load on it. If you impose a load on it that is heavy enough to make sure that all the voids or all the water is squeezed out. Even if you remove the load, what will happen? The soil will remain in that state. So that is the preloading that they're talking about. But it must be done in a certain way, or the load must be heavy enough to make sure that you are able to minimize those voids or remove or squeeze out the water as much as possible, so that you have that consolidated state that you need. So that's the preloading they're talking about. The stabilization by electric and thermal, it's heat and cold temperatures. So heating and freezing of the soil. That's what it is. Frozen soil will have relatively high strength, and heated clays will have low plasticity index and high permeability. So they manipulate the soil, because clay has a way of being cohesive. When we're doing tests in the lab, you'll see clay, when you add water to it, what it does is it will swell, right? But even beyond, before it even we even talk about, you will have a process whereby it's so difficult for you to mix it when you're determining the Atterberg's constant. It's that test is so not nice when you're dealing with clay soil, because the cohesive properties of clay, they're crazy. Therefore, they say you will heat it to make sure that you minimize that property of clay as well. I'm not sure, but you do know that they have clay bricks, all these. So because bricks, even though they will make them with clay, they will heat them or bend them to a certain point whereby they're bent, and even if water is introduced in it, it does not do anything to it because the property or the structure of that soil is completely altered. So that's how they do it. Soil aggregate stabilization is altering the gradation of the soil. So this one is where when you realize that the soil, the particles that you have will not give you the compactive effort or the compaction that you desire, then what you do is you will bring in alternative alternative aggregates to alter the gradation of that soil. So if it was not well graded, then maybe it was kept graded. You introduce finer. If it had bigger particles, you introduce finer. If it did not have bigger particles, then you introduce the bigger particles. Cement stabilization. This is stabilization by cement. Cement is added to the soil to produce the required stability. Safety precaution, very important. Why? Remember I said when we are dealing with the cement, you need to make sure that you wear protective clothes and everything. It's because when you are dealing with cement, it will react. So especially because of the hydration process. So what happens is cement, for it to harden, there is a hydration process, and it includes cement heating up, and then it will harden. So you need to make sure that you take safety precaution. Cement is effective in stabilizing the medium to low plasticity material, but it is difficult to treat fine clay material. The addition of a stabilizing agent to a soil usually results in an increase in moisture content and a decrease in density. Cracking is common in cement-treated layers. Initial cracking and traffic-associated cracking can be expected in this case. So from this, remember, so when we're moving to using stabilizing agents, which is maybe cement, lime, and bitumen, you don't just treat soil with any of those. It depends on the plasticity, and it depends on what do you want to achieve. So specifically, when it comes to cement, they focus on medium to low plasticity material. But they tell you that if you were to use cement as a stabilizing agent, you will have a problem with clay material, right? But things like cracking, they will happen. So when you reading it in the book, please remember to give more attention on that, because cement, it will hydrate, or the hydration process. What will happen is it will heat up, right? And if it's not cured, what will happen is you will have a rapid hardening, which will lead to the cracking. When we're doing cubes in the lab, you will realize that we'll do the cubes today. Tomorrow morning, the following day, we take the cubes and we place them in water. Why are we doing that? Because, okay, cement in its green state. What is the green state? It's a state whereby cement is still trying to set, right? In its green state, you can use it. You can alter its shape and everything. But so once it moves from that state, I think it takes 2 to 4 hours. Once it moves from that state, it's moving towards hardening and strength, right? So because in concrete, you will have different ingredients: cement, aggregates, and sand. Water is one of those. So you mix all those things together, and then when it hardens, it goes in that route of now we want to gain strength, right? So for you to make sure that you get the required strength, you cure the cement or the concrete. You cure it because you want to manipulate or influence the strength gain. Um, In big construction places, they will wrap the columns with plastics, right? In slabs, they will spray them with water or cover them with something just to protect them. That is a curing process, because if I take the cubes, put them in a bath, you'll see we'll put them in water. On site, you can't put them in water. You need to find ways to make sure that you don't lose the moisture because of the heating, right? Because of that heating, you will tend to lose moisture. You don't want to do that. You want to retain all the moisture, and then you use those methods. There are different methods. Just go and look at different methods used to cure concrete, either in the lab. I said in the lab we'll use the water bath, and then outside on site, because the structures are so big, then what do you do to make sure that you have cured the concrete? We talk about concrete because cement is the main ingredient in concrete, and it's the one that influences the strength as much as other ingredients come into play. But you will never have a concrete without the cement. It is the main ingredient. Lime stabilization, they say soils are treated with lime to produce the stability required. During lime stabilization, two basic reactions take place. Rapid and instant improvement that involves the exchange of ions. A pozzolanic reaction that takes place over a period of time, ranging from a few minutes to several months. Lime is most effective when there is a sufficient amount of clay in the soil to react with the lime, with clay. PI is used to determine whether soil is to be treated with cement or lime. That is very important. The question now will come, which soils are suitable for lime? They just told you we focus on soils with high plasticity index. In this case, those will be clay soils. When they were speaking about cement stabilization, they said medium to low plasticity material, and here they say high. So please take note of that. And then they talk about initial. They say initial cracking develops in lime treated layers, with cracks forming rectangles like in cement treated layers, but they are narrower and less extensive. Please look into this deeply. In both cases, you are bound to have cracks, but they are different depending on what stabilizing agent did you use. So please make sure that you are aware of the difference in terms of cracking, because they say these ones are narrower and less extensive, but the ones whereby they were talking about cement, they say initial cracking, and they refer to cracking associated with traffic. So here they say initial cracking, meaning that it's bound to crack. It will crack, but in a certain way. And then when you're dealing with lime, it will crack, but it's different than the cement, if cement is used as a stabilizing agent. And then we're going to move to we're going to move to bitumen stabilization. So soil is treated with bitumen, mostly used in soils with high PI. High PI depending on whether that soil will have, because if the soil will have high plasticity index, but they also talk about sandy soils, it might be a combination of both soils, right? Maybe sandy, it has salt in it, or it has clay in it. So depending, but is mostly used for soils with high plasticity index. Suitability and specification. need to be checked before using any bituminous product as a stabilizing agent. So here they will use bitumen emulsions, whereby in terms of bitumen, they will blow bitumen in water, and then they will change into a product, and then they stabilize with that product. So here you really need to look at the specification, because if you don't get the specification right, it means that you might treat it, but it might not give you the results. Therefore, that's why they say focus on the specifications. They also talk about slopes. A slope is any inclined surface to the horizontal. Why are we talking about slopes? We're talking about slopes because they need to be so some roads on the side of the road, there will be slopes on the side, right? If we don't focus on these, we might have a problem. When you're building, when you put your footing, it's important that you know what you're doing. Like we said, KZN area, it has a lot of slopes. If you're building on that type of area, then you need to know what are different failures that I will expect. Depending, it will be based also on the shear, or what we spoke about, the internal friction of the soil as well. So those things are things that you need to look into. They say a common failure is slippage of an embankment or cutting. So depending on what is causing the slope to fail, they say you are bound to get different types of failures. Water is one of the factors that mostly contributes to the failing, but not water only. We talk about water, air, and sometimes if that area will be exposed to animals, because they're heavy, they have a way uh, of contributing. So types of failures in terms of slopes, you will have rotational. Those are secular and non-secular. You'll have transitional, slip, the ones where they slip, and then you'll have the compound ones. They have examples in your books in terms of pictures of what are those. Slopes, like we said, if we're looking in terms of road, they talk about slope protection, and they in your book they tell you they can use all these things to protect the slopes. So they speak about gabions. These are the gabions. If you see on the side of the road, you see those wire meshes, and then inside them there are fragments of rock. Those are gabions. Hydroseeding is a process whereby they try to make sure that there is vegetation. So they will spray that solution that they have there. It has in it seeds. So then after a while, you'll see that you'll have green vegetation there, depending in terms of what is it that they mostly plant. It will be based on the rooting system of that particular plant, right? Let's make an example. Grass is known for having longer roots. And therefore, if you were to plant here, you will plant that. You will not focus on trees, because trees, they take a very long time to have a rooting system. But grass will have a shorter space to have that a good rooting system, and therefore, because the roots are longer, what they do is then they hold the soil. You know how when if you have an area in a slopey area, if it rains and that area has vegetation in it, at the bottom you are not expecting to have a lot of soil that will settle there. Why? Because all the water gets absorbed by the plant, by the roots. If you don't have that, you have the danger of erosion, soil erosion, and then so that's why. So even when they plant, they try to check first the rooting system and what type in terms of aesthetics as well, and also maintenance. Who will maintain this? Will it be possible to maintain regularly or not? And then that choice is made based on that. They have riprap. This is riprap. You see that it's mostly used in places whereby there are dams, or maybe they're trying to protect from the ocean or the sea. That is the thing. Also in places whereby, after some time, the water keeps coming closer and closer and closer to the residential areas, they end up having this, because you will no longer have a beachfront, because the water is slowly approaching where people must walk. I think in places, this is everywhere. Here in Durban, if you move around the beach, probably you'll see it in PE as well. Everywhere where there is a beach, and probably there was a need to do this, you'll see that they have around South Africa at large. That is a method. They also plant here. They call this planting. So the difference between hydroseeding and planting, here they plant, they bring plants. They will be small, but they bring them and then they plant them individually. Hydroseeding, they spray that solution that has seeds in it. Straw covering, they use straw to cover the sides. Um, and then the last part deals with reinforced earth. Reinforced earth relates to the strengthening of soil to make it withstand high demands. Um, Reinforcement, normally when we speak about reinforcement, what comes into your head mostly it will be reinforcement bars, right? That they use to reinforce concrete so that it holds it has a specific strength. They use formwork. Maybe if you want a round column, you'll have a round formwork. In that column, they have steel bars. I think you've discussed this in drawing. So there will be different tension bars and compression bars they use. So reinforced earth, normally you'll think about reinforcement, you think about that. But in this one, we talk about strengthening the soil, right? So that it withstands high demands or maybe the loading. So most common application include walls, ground slabs, dams, foundation, and embankments. The common types of reinforcement that they use is the steel strips, welded steel grinds, wire mesh, or geosynthetic materials. And this is of great interest to us. Why? Because remember, even with concrete, they're trying to see ways, sustainable ways to produce the same concrete without having to go and use the original ingredients. What are the original ingredients? Cement, aggregates, sand, and water. Normally, we will use clean, potable water. So in that case, they also try to find ways. Can we not use water, reuse water for concrete or whatever? So they check the suitability of water. So they're always coming up with methods, sustainable methods. Why are we doing that? Because it's important to be sustainable. Remember, reuse, recycle. So all those things, even when it comes to construction, it's important. So in terms of geosynthetic materials, these they normally use these right now, and They say it's good because they use polymers relating to plastic, and because plastic is something that is abundant and we don't know how to recycle it most of the time, it kills almost everything that we have. And therefore, that's why it's important to make sure that we try as much as we can to be sustainable. In terms of synthetic materials used to reinforce Earth, please go and check. What are geosynthetic materials first? What is their composition? And what are they, where are they used? And finally, just try to find out, are they sustainable or not? Since it's something that in construction, they are mostly moving towards that route of trying to solve a problem. So that is where we will end with this presentation based on soils. Now what I'll do is I'm going to stop the recording and open the floor for questions.